In this example, we're going to be working with the equation r equals 4 sine theta. And we want to go ahead and take this equation and transform it from polar coordinates into an equation that has rectangular coordinates. So what you see right now is an equation that has an r value and a theta in it. And we want to transform this to an equation that has rectangular coordinates, which means it's going to have an x and a y value, and the r and the theta are going to disappear. Okay, and we have a hint on this one. We have a couple formulas that we can use to help us along the way. I have an equation that says r squared equals x squared plus y squared. That's the equivalent of my Pythagorean theorem. And I also have the equation y equals r sine theta. Well, the problem I'm running into in this question is that I don't see an r squared. So let's go ahead and multiply both sides here by the letter r. Right, that's going to make r squared on our left-hand side. And on this right-hand side, I'm going to rewrite this a little bit. I'm going to get 4 times r times sine of theta. Right, and now we have a couple pieces where we can actually go plug in. Right, let's go with this right side first. In place of this r sine theta, I'm going to go ahead and replace it with the letter y. Right, because anytime I see an r sine theta, I can replace it with a y value. And on my left-hand side, I have an r squared. So anytime I see an r squared, I can actually go ahead and replace it with x squared plus y squared. And in this step, I've actually already answered part of the question here. I have an equation that's in rectangular coordinates. Notice that you only have x's and y's now in your equation. So I've satisfied that first part. The second part asks us to go ahead and identify the graph. So let's go ahead and work with this equation. And I'm going to go ahead and subtract 4y from both sides. And this is going to give us x squared plus y squared minus 4y equals 0. And I left some space here because we're going to go ahead and complete the square on this left-hand side of our equation. I want to gather all my x terms together, all my y terms together, and they already are. So let's go ahead and take a look at our y terms here. This number in front of the y term is a 4. I'm not going to worry about my negative sign for right now. And when I'm completing the square, I'm going to take this number and I'm going to be dividing it by 2. And then I'm going to go ahead and square it. So 4 divided by 2 is going to be 2. And when I square it, I'm going to get positive 4. And remember, you can't just add a number to one side of the equation without adding it to the other side. So I'll go ahead and add 4 to both sides of my equation. And the whole point of doing that is that you have created a perfect square trinomial here with your y terms. Okay, I'm going to go ahead and copy down my x squared term. And we can go ahead and factor this trinomial that's produced with your y terms. Right, this is going to factor into y minus 2 times y minus 2, which is the same thing as y minus 2, the whole thing squared. And on the right-hand side of my equation, I have a 4. And this is actually in kind of standard form of a circle. The number that you see here on this right-hand side is our radius squared. So this actually has a radius of 2 units. And the center of our circle, let me go ahead and put our general form up here. We've got x minus h, the quantity squared, plus y minus k, the quantity squared, equals r squared. Right, and hk in this case is my center. So if we go ahead and pull those values off our equation, our h value is a 0, and our k value here is a 2. So what we actually have is the equation of a circle. The center is located at the point 0, 2, and it has a radius of 2 units if we were going to go graph it.